Hi, I'm Coach Dalton. We're going to be talking about circles here on the SAT math. My previous video was also about circles. We were focusing on just general kind of SAT pet concepts in the realm of circles. Arc length, sectors, that double angle thing, tangent lines, all that kind of stuff. For this video, what I'd like to do is actually go through a bunch of real circle problems. So let's go ahead and start with this one. This one is beyond classic for the SAT. Look what we got here, right? I'm not even going to read the question yet, okay? Just look. Look at this circle. We got this shaded region here, 100 degrees. Let's not even read the question, okay? I'm not even going to read this question. I will, but let's just start by just looking at the picture they give us and let's just imagine what kind of stuff might go on in a problem like this. We've got the sector, we've got the central angle labeled 100 degrees. You remember what we do with a sector of a circle question? Remember, it all comes down to the part over the whole fraction, right? So for this particular question, it's 100 degrees. That's the part, that's the central angle of the sector. And the degrees of the whole circle, what's that? Yeah, it's 360. Okay. So probably this fraction will be involved in some way because what else could we even do, right? Remember what I like to talk about, you want to detach from the anxiety over what you should do and just focus on what you could do with what they give you. They give me a sector, they label it like this. I know I'm going to be doing the part over whole fraction in some way. Now, what I do with that might depend on what they end up asking. So let's actually finally read that. Point C is the center of the circle above. Okay, thanks. What fraction of the area of the circle is the area of the shaded region? What fraction is the shaded region? Well, like I talked about in my previous video, the whole part over whole fraction is going to be consistent, whether we're talking about the shaded area or the area of the sector over the whole area. That's going to be the same fraction as the arc length of this sector over the circumference, the arc length of the whole circle. And that's the same thing as the central angle over the angle of the whole circle, which is always 360. So really all we have to do here is now just reduce this fraction. So I'm going to start by just crossing out these zeros. Now it's 10 over 36. And by the way, I don't have to reduce fractions. I just am doing this so it can fit inside that little, this is one of those student-produced responses question. And on the paper SAT, where this test is from, there's only 4 slots in there. So 10, like the slash of the fraction takes up a slot. So this is be too many. So that's why I'm reducing. But just in general, you don't have to reduce. Do you know that? If you get an answer that's 3 over 6, you can just put that in there, and that's fine. You don't have to make it 1/2. In fact, I recommend you don't make it 1/2. I want you to stop indulging that part of yourself that needs everything to be reduced, unless you have to. Okay, 10 over 36, 10 divided by 2 is 5. Obviously, both these things can be divided by 2 because they're even numbers. And 36 divided by 2, what's that, 18? Is that true? That's true, right? Yeah, because 18 is 2 times 9, and 4 times 9 is 36. So, okay. So 5 over 18, that's our answer here. So, wow. This question ended up asking exactly what we basically set up from the beginning. And we knew this fraction was going to be involved in some way because that's, again, basically the only thing we can do with information like they gave us here. The central angle marked in a shaded sector. Beyond classic SAT. Let's zoom in here because that is not really that big. Okay, this one doesn't give us a picture at all to look at, but that's okay. When there's a picture that we can draw, we should draw it. We always want to have a visual going in a geometry question, right? Not in your mind's eye. Okay, that's how we make mistakes. I know you're so smart and can do all this math in your head all the time. The SAT is different. Remember, we don't want to be doing things in our head. We don't want to be visualizing things in our head like that. It's different because on the SAT, first of all, you've been there already for 2 hours doing a bunch of verbal stuff, scrambling your brain. And also, the wording of questions is tricky and weird. So we want our brains focused on decoding and demystifying that wording, not on also keeping all these circles and numbers in our heads. We want that stuff on the page so we can look at it with our actual eyes. Okay, points A and B lie on a circle with radius 4 meters, and arc AB has length something meters. Okay, wherever I got this question from, something didn't come out in translation, but they say what the length is coming up. Let's just first start by drawing the circle. Doesn't have to be pretty, and this is definitely not. Points A and B. See, nothing wrong with that. Lie on a circle with radius 4 meters. So let's see here. I'm just going to go ahead and connect to both points and call that 4 meters. I connected to both points because I'm drawing a little slice of the pie there, a little sector of a circle. Why am I doing that? They didn't ask me to do that. I'm doing that because after doing so many circle questions, and like we talked about on the previous video, I just know that they are so in love with sectors of circles. So if I have an opportunity to draw a sector, I'll do it. Okay. The length 4 pi over 5 of arc AB is what fraction of the circumference of the circle? Wow, basically the same kind of question. The previous question was about the area of the sector is what fraction of the area of the circle. This one is the arc length is what fraction of the circumference. Same situation, right? It's another part over whole situation. So they tell us that the length of the arc is 4 pi over 4. So they mention the circumference of the circle, right? So let's find that circumference. You want to check your formula page. Make sure you're not messing up how the circumference works. Circumference equals 2 pi r. Our radius is 4. So that's 8 pi. And now for our part over whole fraction, that's going to be 4 pi over 5 over 8 pi. We have a fraction within a fraction. It's okay. No reason to freak out over here. It's just like saying 4 pi over 5 times 1 over 8 pi. The pi's cancel. We're going to be left with, oh, my face is blocking what it's going to be. 4 over 40. Can you see that? No. There we go. 4 over 40. Just leave it at that. I mean, sure, I could make it 1/10. But why? It'll fit in the grid. That's the answer, right? 4 pi's cancel. Yeah, I think we're good here. So let's just keep going. Another just beyond classic SAT situation. Look at this. See what I mean? Like, once again, we got a sector of a circle over here. The circle above has center O. Okay, whatever. The length of arc ADC, so this length is 5 pi. Let's just go ahead and label that. That's 5 pi. And x is 100, so that central angle is 100. What is the length of arc ABC? Okay, there's a couple ways to do this. I'm going to do it once again in the part over whole way because I think that's just such a robust strategy for questions like this. So the arc length is 5 pi. Oh, but let's focus on the angle stuff because they give us that the angle, central angle is 100, right? And we always know what the whole angle of the circle is, of course, right? Yeah, 360. And that's going to equal part 5 pi over the whole. Now, what does 5 pi represent? It's the arc length, right? The length of arc ADC. So if 5 pi is the part, the whole is going to be the whole circumference. I'm just going to call that x. 100 over 360. Didn't we just do that for a different problem? It ended up being, I think we canceled the, yeah, it ended up being 5 over 18, right? Yeah, so we cancel those zeros, so we reduce that. 5 over 18 equals 5 pi over x. Now, ordinarily, I would just get to cross multiplying, but look at the gift we were just given. Look at the beauty of what reducing this fraction first opened up in our world over here. 5 over 18 equals 5 pi over what? Well, what would this have to be to make this whole thing be true? I mean, look, these numerators are almost the same, right? 5 and 5 pi. So if this one's 18, then this one's got to be, yeah, 18 pi. And it looks like that's C, right? So we're done. No. No, we're not done. Did they ask for the circumference? No, that's what that is, right? The part, we're doing part over whole. They asked for a different thing, didn't they? They asked for the length of arc ABC, the other part. So we just found that the circumference is 18 pi. So what we need to do is do the whole circumference, 18 pi, and subtract the arc length we were given, and that'll give us everything else, 13 pi. Oof, close one, right? Remember, just because you see an answer that's in the choices, that doesn't mean you're right. I know this is a tough pill to swallow, but really the only way we can ever really know what's going on is if our answer is not in the choices. Because if our answer is not in the choices, at least we know we're wrong. At least we know something went wrong. Whereas if our answer is in the choices, well, what does that mean? It means that either we're right or we fell for one of the 3 traps, the 3 easy to fall into traps as determined by College Board. And I may as well say this now as well. Notice that the other answers, they're not just random other numbers. They often are correct numbers, 18 pi, for example, that we legitimately got on the way to the actual answer. So it's always good to be in the habit of double checking what they were actually asking for before finalizing our answer. Remember, like I like to say, this really is more of a reading test than you would like to admit, than you would like to believe. What else we got here? So we're still on a sector of a circle situation, right? We still have the sector mark. Notice how much they love that, this part of the whole, the slice of the pie situation. This time they're telling us not drawn to scale, but whatever, I'm not scared of that. In the circle above, point A is the center. And the length of arc BC is 2/5 of the circumference of the circle. What is the value of x? Okay. See what I mean? How they just ask us the same crap over and over again? They're not creative in the actual real concepts that they keep testing continuously. but they are creative in the way they find to repackage the same stuff over and over and over again. So remember what we've been saying, right? That this piece of the circle, this part of the whole, is a fraction of the circle. And that fraction is consistent no matter how we measure the circle, right? This arc length BC is some fraction over the circumference. And actually, they tell us in this question that it's 2/5 of the circumference. So that means that this arc, BC, is 2/5 of the circumference. That means that the area of this sector, ABC, is 2/5 of the area of the circle. And it means that X is the angle, the central angle is 2/5 of 360. Yup. So that's all we got to do here. Just do 2/5 of 360, and that'll do it. What is that, by the way? Well, if it were 360, so let's see. I mean, what I'm doing right now is I'm going to do 360 divided by 5 and then multiply it by 2. It's not a calculator question, by the way. So I'm not using it. Well, if it were 360 divided by 10, then it would obviously be 36. So then 360 divided by 5 should be double that, double 36, right? Which is 72. So end up with 2 times 72. End up with 144. Is that correct? Let me know in the comments if that's correct, but I'm pretty sure we're good here. Because 5 times this would be 10. Yeah, that works out. Little shortcut for you. Okay, let's look at this one. So once again, before I even look at the question, I'm going to check out what they're telling us in the circle. And once again, look at this, right? We got our sector. Though this time, this is one of those other circles we saw in the previous video, this like Star Trek looking symbol. And you remember what we learned, right, about this angle A, right? Remember how this angle A is the inscribed angle and this angle P is called the central angle? Remember the relationship here? It's the central angle is double the length of the inscribed angle. So whatever this angle is here, double that, and that's going to be the central angle here. Okay, point P is the center of the circle in the figure shown. What is the value of X? Okay. This is a little weird of a question. And we have kind of a weird shape, don't we? And once again, it's this like Star Trek looking, badge thing. Now, one of my policies when it comes to basically any shape that is more complicated than a rectangle, almost always, is to just chop up the shape in some way. And if we're dealing with a circle question, like a weird shape that's inscribed in a circle, or I don't know if we'd call this shape inscribed, though definitely 3 of the vertices of the shape are on the circle. So, I mean, whatever. The point is, if you're dealing with a shape that's weirder than a rectangle, you want to chop it up into smaller shapes. And if you're dealing with a shape that's in a circle, the way to chop it up is almost always going to be to draw a radius or more radii. There's really only one to draw here, right? From P to A. Well, I guess we could have drawn in any direction, but this way we're actually including the points on the shape, point A there. And remember what we talked about in the previous video, right? About the reason the SAT is so into circles is because it enables them to give us like secret information about what sides are the same. So the fact that we now have 3 radii drawn, we know that these are all equal length. Okay? So we've chopped up the shape. We've chopped it up into 2 triangles. And because each triangle has 2 sides that are radii of the circle, that means each triangle is an isosceles triangle. Meaning 2 sides are the same, and therefore 2 angles are the same. So if that angle here is 25, it means this angle there is 25, and this angle there is 25. So that means that angle A is 50, because 25 and 25. And the central angle is going to be double 50, so it's going to be 100. Really, not too bad after all, eh? Ah, interesting. Points A, B, and C lie on the circle as shown. What is the measure in degrees of arc AC? Okay, we didn't talk about this in the previous video about the measure of an arc in degrees. So when you have an arc AC, they measure it in a couple different ways. One of them is, of course, just the piece of the circumference, like we've talked about, like the literal length of the arc. But they'll also use this term measure of the arc. And I just want to say right away, there's an answer choice I want to just get rid of. You know why that is? And you know which one it is? It's A. Because it's probably a trap, right? I mean, we're on number 16. And it's a multiple choice question, so that means if we're on number 16, it's multiple choice. I guess this problem came from the calculator section. And there are 30 multiple choice questions in the calculator section. And the way I see it, I always see the math sections in terms of halves. So there's the first half of the multiple choice, 1 through 15 in the calculator, and the second half, 16 through 30. And then you have the student-produced responses, but that's like a separate section. So if I'm in the second half, probably the answer is not going to be a number that's right in the picture. If I can get my answer without doing any math, then probably it's a trap answer if I'm in the second half of the section. So I just want to point that out in general because sometimes you may not know how to do a hard question, but you can at least be a little strategic with the answers before just guessing C or whatever it is you do. Try to think like a test writer and try to look at the choices and see, okay, well, which of these seems like a trap answer? Which of these is an answer that someone might pick if they had no idea what to do and they were just looking for something obvious? Number 16 is not going to be something obvious like that. We're in the second half now. So 55 is probably a trap, so I'm getting rid of it. So if I had no idea what to do, I'd guess from one of the other 3. Okay, next thing I want to do with this circle, though, is I want to basically make it look like other circle questions we deal with. And what is every other circle question by the way, I didn't just pick these circle questions super specifically to just make a point. I went through several real SATs and literally screenshotted all the circle questions I could find. So it isn't like I'm contriving this pattern just to make a point, make some sad point. This is their thing, is doing the whole sector thing. These are the things that come up again and again. So I'm looking at a question like this, and the first thing I think is, well, something's missing. Don't I usually have a sector marked in a circle question? So let's go ahead and do that. Let's go ahead and draw this where the sector would be from the center. I don't love the way that looks. But I'm not gonna be doing this all the time. In fact, my point is that we don't need to be good artists. In fact, that better be my point, because you've already seen how I draw some of these circles over here. I'm not gonna let that stand in the way of getting a visual going, of course. So I've made my sector of a circle here. And here's just the way to do it. The measure of the arc is the measure of the central angle. So here we have the inscribed angle is 55. Remember the relationship here between that and the central angle? It's double that, 110. And once again, the measure of the central angle is the measure of the arc for that central angle. So the answer is 110. See a weird circle question? I ask myself, okay, well, what kind of stuff do I usually do in circle questions? What kind of stuff do I usually see in circle questions? Well, I often see a little sector marked there, right? So how about we do that? And maybe we'll figure it out from there. I'm not getting all bogged down in, but how am I going to get to the final answer? I'm just looking at one step ahead of me. I'm just looking, not even one step ahead. I'm looking at the step that I'm on. Okay, well, what can I do in this step to move the problem forward in some way? You get so paralyzed by your lack of ability to see all the way to the end of the question that you don't even start the problem. And that's what's holding you back. Okay. In the xy plane above, the circle has center HK and radius 10. What is the value of K? Well, why don't you tell me what are we going to do here? First, I just look at this circle. What do you think I want to do when I look at this circle? When I look at this circle, what do you think I just feel is missing? And I just have this uncontrollable urge to make it be there. Yeah. Draw a couple radii. Again, I mean the audacity of making this the plural of radius. That's how you spell it too, radii. Okay. I draw a couple radii, and look what I've done. I've now created a sector of a circle. Can you believe how many circle questions they ask involving sectors and part over whole and whatever? Okay, so they told us it has a radius 10. Now we can say that that's 10, and that's 10. And how nice. What is the value of K? Okay, well, let's talk about this. What is K? I mean, K is clearly the y coordinate of the center of the circle over here. Well, this one's a little bit different, isn't it? And I think we should draw one more line, actually. Because think of it this way. The y coordinate of a point is literally the vertical distance from that point down to the x-axis. And this is something I'm going to go into more detail about when I do my triangle series. But just like how in circle questions, a good idea is to draw radii. Also a good idea in geometry questions in general is see if you can make right triangles by drawing lines. Now, sometimes you accomplish both those things at once. Sometimes drawing a radius is also drawing a hypotenuse and you form a right triangle, or drawing some other side of a right triangle. The SAT is in love with right triangles. So if you have an opportunity to make a right triangle, especially a relevant right triangle like here, since you're trying to solve for K, that's like the vertical distance there from the center to the x-axis. Look at that. I drew a line straight down. Now I have a right triangle. Well, I have two right triangles, but let's just focus on one, okay? All right. Now we have a little more information, don't we? We know that this point is 4, 0, and this point is 20, 0. So I know that this entire distance is 20 minus 4, 16. I just split it in half, and that's 8. So look what I have. I have two sides of a right triangle, don't I? And if we have two sides of a right triangle, we can always find the third side. Now, this happens to be a calculator question. So we could definitely just use the Pythagorean theorem to find that third side. But I don't even need the Pythagorean theorem to know that this is 6. I don't even need a calculator for that. I don't even need the theorem at all. You know how I did that? Well, again, this is something that we'll go into more detail about when I do my triangle videos, but there are these classic Pythagorean triples, not drawn to scale. 3, 4, 5 is a classic one. They're just right triangles just to know. So if one side is 3 and another side is 4, you know the hypotenuse is 5, okay? If the hypotenuse is 5 and one side is 4, you know the missing side is 3. But it also applies to multiples of 3, 4, 5 triangles, right? 3, 4, 5 times 2, 6, 8, 10. 3, 4, 5 times 3, 9, 12, 15. 3, 4, 5 times 4, 12, 16, 20, and so on. Again, we'll go into more detail about on triangle day, whenever that is. But that's how I figured out that this was 6. But again, it's a calculator question. You could do Pythagorean. And honestly, even these numbers aren't even too bad to do without a calculator. 10 squared is 100, 8 squared is 64, 100 minus 64 is 36. You know. Okay. I'm not even going to read this question yet. Just look at the picture. Just look at this picture. What do you think I want to do right now with this picture? What do you think I just feel the pain in my heart of not seeing right now? What just almost has to be the thing we're going to do here? Yeah, it's probably going to be drawing some radii, right? Because look, now we've created a little sector of a circle, and we just know how in love they are with stuff like that. So you see, this is how we can kind of walk ourselves through problems that seem a little weird. Just think about what has happened in the past. Remember, they're not that creative. They're just they're only creative in the packaging. They just repackage these different concepts. It's up to us to see, okay, well, usually they have some like a sector drawn with their, a little piece of the circle there, a little slice of the pie. So how about we do that? And then go from there. That's what we've done in the past. Even if you can't immediately see the value of that, even if you can't immediately see how that'll help, that's the kind of stuff you want to do to sort of get yourself out of a jam over here. Okay, let us, no, not drawn to scale, whatever. In the circle shown, point O is the center, okay, whatever, and diameter UX bisects WY. UX bisects WY, okay, whatever. At point Z. So, bisecting means you cut it in half. So now we know that WZ and ZY are equal, whatever. The radius of the circle is 6, so let's label our newly drawn radius a 6, and XZ is 2. Okay. If WZ is the square root of x, what is the value of x? Okay. Well, before we get into the specifics of what to actually do next, let's see, are there any other things we can label here. Well, they told us that the radius was OX. I'm sorry, that the radius is 6. So look at all these radii we have. We have the ones that we drew. We have this one over here that they drew, OU. We have that OX one that I just mentioned. We got 6s all over the place. And I can't help but notice that when we drew the radius, we made a hypotenuse to what looks to me like a right triangle, which is such a good sign, by the way. What I was talking about in the previous question about how, like, sometimes drawing a radius also creates a right triangle. That's such a good sign that we're just doing the right thing, because they're so in love with right triangles on this test. They're so in love with barely hidden right triangles, secret right triangles. So if you can draw a line that uncovers a right triangle, well, you're probably speaking the SAT's language in that case. So it's probably on the right track. Now I know what you're thinking. Well, how do we know it's a right triangle? Well, there are ways to know, but I'd rather focus on this way of looking at it. If this is a right triangle, which it looks like, by the way, but I know it doesn't prove anything to you, but if this is a right triangle, can we maybe find out the length of WZ? Maybe it's going to be a Pythagorean situation. So I can see a path to figuring that out. If it's not a right triangle, is there a path to finding that side? Do we know what's going on there? Do you have any ideas? And if you don't, then how about you just follow the path that has the assumption in it? Like, if you have two paths in front of you, and one of them involves assuming something is true that you're not 100% sure is true, and the other one involves not making that assumption and therefore having no idea what to do, it's really not much of a choice, is it? You go with the path that has the assumption in it. So we know that this side is 2 over here. We know that this whole side, OX, the radius, is 6. So now we know that OZ is 4. So let's just kind of redraw that right triangle over here. I know that the hypotenuse is 6 because that's the radius. I know that the height there is 4. And now we can do our wonderful Pythagorean theorem. A squared plus B squared equals C squared. Let's see here. I'll make A the 4. 4 squared plus B squared equals 6 squared. 16 plus B squared equals 36. B squared equals 20, right? Yeah. So B equals the square root of 20. Now, we can't select a square root sign in this. Let's go ahead and look back at the way they worded that question and see what's going on here. They're saying WZ is root X. And what is the value of X? Okay, so we found that the length of WZ is root 20. Okay, so that means that X is 20. We could have simplified that radical into what? Something like 2 root 5 or something. But notice they said that WZ is root X. So we want to keep it in that form, root something. Oof. Sneaky. Sneaky thing. Remember, it's a secret reading test. This question had a different format because it comes from a more recent test that someone just copied or retyped or something. The perimeter of a square inscribed in a circle is 30 inches. The radius of the circle is X root 2 inches. What is the value of X? Okay, so I'm going to draw this stuff here. I'm going to draw this circle. Not drawn to scale. It doesn't do too bad. Now they tell us that the perimeter of the square is 30. So what does that mean each side is? Because we can't really like label a perimeter onto a picture. We can label lengths of things. Well, all sides of a square are equal length. So just gotta divide the perimeter by 4, which is unfortunate, isn't it? Because 30 over 4 isn't really pretty. I mean, it's not an integer, you know. I guess we can reduce this to 15 over 2. Ugh, unfortunate. The radius of the circle is x root 2 inches. Okay, so now we're talking radius. So we should probably draw a radius. Now there's many different directions where we should draw it. But you know where the good one is? The good place to draw it? It's if we draw a diagonal across the square. I mean, I realize that's drawing a diameter, but it's like drawing 2 radii, right? You know why that's smart to do? It's because we're drawing something that has relevance for both shapes. If they're combining 2 shapes, a square and a circle, we should draw some stuff that has meaning for both shapes. So this diagonal is not only the diagonal of the square, hitting 2 of the corners, it's also the diameter of the circle, or double the radius. And also, look what else we've done. We've also sliced the square into 2 halves. And you know what that does when you slice a square into 2 halves diagonally? You know what that creates? We're going to talk about this again when we do triangles, but that creates a certain kind of triangle. You have any theories about what kind of triangle that might be? Considering that we see a root 2 in the question? Check your formula page. Where do we see root 2's show up on this test, huh? Oh, is it in a 45, 45, 90 triangle? Yeah. Well, isn't that what we have here? 2 45, 45, 90s? I mean, a 45, 45, 90 is just another term for an isosceles right triangle, right? It's a right triangle. We know this is a right angle here because it's a square, and all the corners are going to be right angles. We know these 2 sides are equal because it's a square, and so all the sides are equal. So don't we have 2 45, 45, 90s? And the root 2 should be a giveaway as well. Okay, so the radius of the circle is x root 2. So diameter is going to be double that. So 2x root 2. Now, do you know how (45, 45, 90s work? It's like x root 2. Oh, I shouldn't use x because they're using x. I don't want to be confusing over here. Let's I think this is often said with s anyway. I don't like drawing s's though because they look like 5s. I'm gonna call it y just for this. Y root 2. That's how the sides of a 45, 45, 90 work, right? So it looks like our 15 root 2 is our side, and our 2x root 2 is our, my root 2 over here. So that means that 15 over 2 root 2 equals 2x root 2. Okay. Well, kind of weird. But, I mean, it's okay. I mean, just all the fractions and radicals are kind of weirding me out. But the radicals are about to go away, right? Root 2 and root 2 are on both sides. They can go away. So now we have 15 over 2 equals 2x. And they want to know what the value of x is? I guess we can just divide both sides by 2. I know it's kind of a wacky thing to get. 15 over 2, but that's just like saying 15 over 2 times a half, which is like 15 over 4. Kind of a weird answer. But hey, it is number 20. It is the no calculator section, so it's the last, it's like the last one. So it makes sense, it's a little weird. A square is inscribed in a circle with radius 6 root 2 inches. What is the perimeter of the square in inches? Also a number 20. Also a no calculator. So also the last question. And also a square inscribed in a circle. So once again, let's go ahead and get that drawn over here. Circle. Circle. Square. Square is inscribed in a circle with radius 6 root 2. So once again, you remember how we're going to draw this, right? I'm going to draw the whole diagonal or the whole diameter. And since I'm drawing the whole diameter, I know that it's actually double the length of the radius. It's going to be 12 root 2. And since now we just know that more in our souls about how you slice a square up and it's two 45, 45, 90s. Well, now we remember how this works? How 45, 45, 90s work? X root 2? Well, the hypotenuse is clearly 12 root 2. So that means that each side of the triangle is 12. 12, 12. So what's the perimeter? Remember, not area. They could have asked for area. We got to be careful. What's the perimeter? 4 times 12. 12 plus 12 plus 12 plus 12. 48. This one was a bit more chill than that previous one. Finally, we get into some circle equation questions. I saved these for last because they're kind of in a different category. They're kind of geometry, but not in the same way as all the other circle questions are. Like, we're not going to use the formula page ever for circle equation questions. These more come down to, one, understanding how a circle equation is like built, like what it means. So just to review that, we got x minus h squared plus y minus k squared equals r squared. The point hk is the center. So notice that the signs are always going to be switched over here, right? Because x minus h, y minus k, always the way it is in parentheses in these kinds of equations, right? Just like when you factor a quadratic, or when you see a quadratic equation in vertex form, the stuff in parentheses, like the sign in front of the number in parentheses, is always going to represent the opposite of what's going on. I'll show you an example in a second. And the r represents what it always does in a circle question, right? The radius. So let's read this. The equation x squared plus y minus 1 squared equals 49 represents circle A. So right away, let's just figure out what the center is here. Let's just to practice that. The center of this circle is going to be 0, positive 1, right? Because once again, the signs are switched. I said y minus 1, that means the y coordinate is positive 1. and equals 49. That means that the radius is 7, because the equation, when it's in standard form, always equals the radius squared. Okay, so that's circle A. Circle B is obtained by shifting circle A down 2 units in the xy plane. Which of the following equations represents circle B? Okay, so this is the center of A. Now let's talk about circle B. First of all, for shifting something down or up, like up and down, it's only going to affect the y part of the equation, right? So I think we can just get rid of any choice that is keeping the y part the same as it was. Like, we know that the original equation is y minus 1 squared, so any equation that still has the y minus 1 squared, we can get rid of. Because the y part gets affected by moving something up and down. That makes sense, right? Now, I'm going to show you how to answer this problem for reals, but I'd like to give you a little glimpse into the way I see this kind of thing. Notice that this is number 25. So if we're on 25, we're in the calculator section, and we're in the second half. We're pretty late in the section, right? Remember, there's only 30 multiple choice questions in the calculator, so 25 is up there. So does one of these answers seem a little like suspicious to you? Meaning a little too good to be true? Meaning if someone didn't really know what they were doing, they might just assume the answer was that pretty quickly. Which answer do you think that is? What do you think I'm talking about here? Down 2 units. Well, going down 2, that means that we want to subtract 2, right? -1 minus 2 becomes -3. Again, doesn't that just seem too good to be true? It doesn't automatically make B wrong, but it does mean that B is a bit of a suspicious answer. So it's probably a trap. So if I wasn't quite sure how to do this question, I would definitely want to eliminate B, because it just seems like that's too easy for number 25. I know that you want these very specific explanations for how you actually arrive at the right answer, and I'm going to give you that. But let's just be real. On test day, you might not really have the luxury of being able to solve everything in what you think is the proper, appropriate, official way to do it. You might have to get your hands dirty and use some of these, more guerrilla tactics that I enjoy. So that's when you want to be kind of aware of where you are in the tests, and you want to start thinking like a test writer and thinking, well, I'm pretty far in the section, so probably there'll be some solid trap answers here. So which one seems like a trap answer? And then you can cross those out. And then maybe instead of guessing between 4 choices, maybe you're guessing between 3 or between 2. Or maybe you can narrow it down to 1 choice just using that tactic. This test is more than a test of your math knowledge. It's also a test of your will. But let's go ahead and just do it for reals, just to do that, right? So we know that it's shifted down 2 units. So the original center of A is 0, -1. So that means that the center B is going to be, what's 1 shifted down 2? It's going to be 0, 1 minus 2, 0, -1. And how is that going to look in the equation? Well, we know that the x squared part's unaffected. If the center is actually 0, -1, that means the y part's going to be y opposite sign, right? +1 squared. And that's D. So that's the official boring way of how to get the answer. But I think it's much cooler to just be able to spot that, well, A and C are out because we know that it's the Y part that's going to be affected in some way. And B is out as well because it just looks like trap. I have an issue with my K's here. Just saying. And it's not like doing it in the official way takes that long or anything, but I just want to try to stimulate that part of your mind over here. Because I want you to give yourself permission to be using guerrilla tactics on this test when it's time to do them. And the time is when you don't really know what the official way to do a question is. Because the plan can't be, oh, you'll just know how to do every question officially. Because you can't plan for that. You can practice and prep and be pretty close to that situation happening. But at the end of the day, the plan can't be, I'll just know what to do every time. That's not a plan. A plan doesn't sound like, I'll know what to do. A plan sounds like, if I'm in a situation where I don't know what to do, then I will do blank. That's a plan. So here's our last circle question of the day here. It's another circle equation question. So let's just go ahead and read it. In the xy plane, the graph of 2x squared minus 6x plus 2y squared plus 2y equals 45 is a circle. What is the radius of the circle? Okay. They gave us that equation. But notice that the equation is not in that form we were talking about in the previous question, right? The x minus h squared plus y minus k squared equals r squared. If an equation of a circle is in this form up here, then we can look at it and see the radius. Well, it's going to be the radius squared, but we just got to take the square root of this number here, and that's our radius. We can also look at it and get the center. The center is going to be hk. But if the equation is not in this form, this like parentheses squared stuff going on, if it's like this, an x squared term and an x term and a y squared term and a y, if it's like this, it tells us nothing. Just like how they can give you a linear equation, the equation of a line in different forms, but it'll only really tell us something if it's in y equals mx plus b form. We can look at it and get the slope and the y-intercept. Or parabola equations. There's different forms of a quadratic equation, and depending on what form they give it to you in, it can tell you different things. If it's in standard form, it can tell you the y-intercept. If it's in a factored form, it can tell you the x-intercepts. If it's in vertex form, guess what it'll tell you? So a circle equation in this form tells us nothing. So our job is to get this into this form up here. Okay. The way we do that is by completing the square. Now, I don't know if that freaks you out or bothers you or bums you out or whatever. I never was confident in completing the square back when I was in school, but I think it's probably because I had some crappy math teacher that year. It's amazing how impactful that is when you have a crappy math teacher for one semester where you learn something and you're just basically never confident about that thing ever again for the rest of your life. Until you see my videos, of course. So we're going to use completing the square. It's going to be fine. I'm going to start by just rewriting the equation. That's a nice habit to be in, right? 2x squared minus 6x plus 2y squared plus 2y equals 45. Okay. Here's the first thing you want to do when you complete the square. You want to make sure that there's no number in front of the squared terms. Right now it's 2x squared and 2y squared. Let's get rid of that. Let's divide both sides by 2. That's going to give us now, I'm going to rewrite the whole thing down here, x squared minus 3x. I'm going to leave a space, you'll see why, plus y squared plus y, leave a space, equals 45 over 2. I'm going to change the color over here. So now the fun begins. Now I want you to direct your focus on the x term. not the x squared term now, just the x term. Look at the number in front of it. It's negative 3. So here's what I want you to do. I want you to cut that in half. And let's just keep it simple. I know this is a calculator question. I could be doing this with decimal stuff. I don't have my calculator on me, so I'm just doing it with fractions. We'll see if it works out. I do see it 6.5 in the answer choices, so maybe decimal needs to be involved here. But I'm just going to keep it simple with the fractions, but calculator works fine too. So negative 3 cut in half is just negative 3 halves, right? Negative 3 over 2. So what I'm going to do is I'm going to square that. What's that? 9/4. Add 9/4 over here and over here. Now let's do the same thing with the y. What number's in front of the y? Well, nothing, so a 1 is there. So, two-step process. First, we cut it in half. What's 1 cut in half? It's a half. Now, square that. That's a 4th. Add a 4th here. Add a 4th here. And now we can go ahead and get into the actual form. I'm going to shift over to the left here. It's going to be x something squared plus y something squared equals. Now, honestly, really, we just need the radius over here, or the information over here, because that's going to tell us what the radius is. We don't really need to know what the center is, so I'm going to hold off on that for now. This question is asking what the radius, so let's just focus on that. Let's just get this into all the same denominator. These are over 4, so 4 divided over 2, that's like saying 90 over 4 plus 9/4 plus 1/4. 9/4 plus 1/4 is 10/4. 10/4 plus 90/4 is 100/4, which is 25. So now I know that r squared is 25, meaning r is 5. Let's just finish the center here just to, be fun over here. The numbers that go inside the parentheses now, well, these are just the numbers we first got when we cut this stuff in half. So negative 3 cut in half was negative 3 halves. 1 cut in half was 1 half. So just bring this down here to get our final full equation. So now we know that the center of the circle is positive 3 halves, comma, negative 1 half. But they didn't ask us for that anyway, so kind of an afterthought over here. Well, I think that's enough circle stuff for now. I think next I'll tackle some triangles and yeah. So like and subscribe if you want to see more math content, SAT math content broken down in sort of my way over here. Leave a comment if you have questions about anything like this or requests about certain problems or certain concepts I should do. Coach Dalton Foster at gmail.com. You can apply to work with me. Check out the Mathochist subreddit, r/Mathochist. I post daily stuff there. I'll see you later.